right, guys, so these last bit of notes are over what we call composition of isometries. So composition of isometries is a transformation that preserves length. So translations, rotations, and reflections are all considered isometries. A composition of isometries is two or more transformations that form a new image. We're just going to look at two. We won't do more than two. So when you're doing a composition of isometries, you're basically doing a couple of um, different translations or transformations. In a composition of isometries, the second transformation is always done first. This right here, this is the key thing you need to know from this unit. You need to know that when you have a composition of isometries, the second transformation always goes first, no matter what. So, for example, if you have something like this where you're taking the reflection of something over y equals 3 and translating it 0 units in the x, 3 in the y, you want to translate first, then reflect it. So, since translation comes second, that's what you do first. This is actually specifically called a glide reflection, and that's a composition that's made up of a translation followed by a reflection. Okay, so we're going to do an example of a glide reflection here in a second, but again, before I do that, it is super, super important that you remember this right here. You always do whatever comes second first. Okay, so if we do an example here where we have what we call a glide, let me zoom in a little bit more so it all fits on here. Okay, so we're going to do a glide reflection. There we go. Of triangle ONM, and it has vertices O at -4, 2. So -4, 2 is right there. Oops, wasn't on the pen, my bad. And then N is at -1, 6. So we've got O here, we got N here, and then M is at 0, 3, which is right here. There's our M. Okay, and again, we are going to do the following glide reflection. So we're reflecting over the line y equals 0 and translating 5 units in the x, -1 in the y. So the first thing that you need to do is you do your translation first. So that's what we're going to do first. We're going to take our original image here and we're going to translate it 5 units to the right and then 1 unit down. So when we do that, when we go 5 to the right and 1 unit down for O, O prime ends up being 1, 1. So we end up right here. And then N, when you go 5 to the right, down 1, you end up with 4, 5. So you're going to end up right here. So here's O prime, here's N prime, and then M, when you go 5 to the right and down 1, you end up at 5, 2. So 5, 2 right here. And there is your M prime. Okay. Now, once you have that, you want to go ahead and do your reflection. And when you do your reflection, you are now reflecting your new pre-image here. So this became the image, and now this is going to now be your new pre-image. And we're reflecting over the line where y is 0. Well, that's the x-axis. So we're reflecting over the x-axis here. So when we reflect, O prime is 1 unit above, so you're going to end up 1 unit below. So O prime ends up being 1, -1. And this actually, since you already have an O prime, you would label this O double prime because you already have an O prime, so we would just make it a double prime. N is 5 above, so you're going to go 5 below, and you're going to end up at 4, -5. So right here. And then M prime is specifically 2 above, so you're going to go 2 below here, and you're going to end up at 5, -2. And you connect the dots. I forgot to put the N prime, double prime, M double prime. And this right here is your final answer. So again, that's a composition of isometries. What you need to know for your quest. The big thing here is understanding that when you have this situation, you always want to translate first. So whatever comes second is what you do first. Other than that, that's all for today. Have a good rest of your day, and I'll see you soon. Bye.